Hello Year 11, welcome to our 5th video here for our 10th topic. We are looking at the perimeter of circular and composite shapes. Perimeter, distance around the outside of a shape, right? Add all the edges together. Add all the edges together, gives you the perimeter. Now when we get to circles, well, it's a bit different because they're not straight lines. We can't measure them, we're going to have to calculate them. Now, the perimeter of a circle we call a circumference. The distance from the center of the circle to the circumference is called a radius. 2 radii might make a diameter. That's a straight line that joins 2 places on the circumference and passes through the center. Okay, it's equal in length to 2 radii. And we've got a formula here for calculating the circumference of a circle. Get ready. You ready? Twinkle, twinkle, little star, circumference equals 2 pi r. Yeah, that's fabulous. That's going viral for sure. Now, 2 pi r or pi times the diameter. Can't believe I just sang on this video. Anyway, you'll probably remember now because it sounds so stupid. Circumference equals 2 pi r or pi d. Okay, let's have a look here. Sometimes perimeter questions can seem a bit too simple, so we kind of try to mix them up. I would recommend drawing on your diagrams. Okay, because if we have a look here, you can see, oh, there's some things missing. I've got a 5 here, a 7 here, a 4 here, and a 15, but what on earth is going on here and here? Well, consider this. Right, what happens if I draw a line? Oops, not working very well. What happens if I draw a line across there? This little dotted line. Okay, well, I know that's 4. 4 plus something, 4, and that one's 5. So altogether it must be 9 there, yep. Pretty scruffy drawing, okay, but can we see we've got a 4 here and a 5 there, so altogether that's a 9. Now I can do the same thing down here, do my scruffy line. Now it's 15 all the way, but I know that part of it's 7, so 7 plus what? 7 plus 8, right, so that part's 8, so that part there must be 8. Oh, that's not supposed to happen. Oh, that's not supposed to happen either. It always plays up when I do an 8. So, now I can, oh, blown up again. I didn't even write an 8. So, let's say P for perimeter equals, let's work our way around clockwise fashion. 8 plus 5 plus 7 plus 4 plus 15 plus 9, and we're back to where we started from. So what is that? 13, 20, 24, 39, 48. Is that okay? I should be happy enough with that. There's a 9 there and a 15 there. 9 plus 15 equals 24, 48. Okay, that's all good. Equals 48 meters. That's how we do perimeter. Okay, maybe you've got a missing side and you'll need to work it out. Let's have a look at something else. Oh, what's going on here? I am missing a side, but it's not parallel to one of the others, so I can't sort of transfer it over. But again, I am going to draw something. So, again, watch. Let's draw a line down here. Now, I know that side there is a 3. Now, 7 up the top, so 7 down the bottom here. That makes this part over here 4. I made that a right angle. So now I've got this right angle triangle here, and I could say that. Let's call this x, because I like using x's. Let's say x squared, because it's a right angle triangle, 3 squared plus 4 squared means that x squared equals 25, means that x equals 5. When you're working these things out and you've got a diagram, write it on there, okay? In case you get lost somewhere down the track, you won't make a mistake. Okay, so now my perimeter becomes fairly easy to work out. My perimeter equals 7 plus 5 plus, just be careful here, the 4 and 11, no, just that 11, plus 3, and I've got 12, 23, 26, don't forget your units, 26 centimeters. Right, now we've got to keep moving along because there is a lot to do here. These exercises start to get pretty busy. Now an arc is part of the circumference of a circle, right? It's part of that curve, not the whole lot. If I take an arc and join the two ends of it up with straight line back to the center of the circle, that'd be radii. So 2 radii and an arc. It's going to make something that either looks like a piece of pizza or maybe like Pac-Man. Right, it's called a sector. Sector. Piece of pizza or a Pac-Man is a sector. Now, the length of an arc, how long is that thing? Well, it's some fraction of the circumference. Now, I find the angle between the 2 radii, right? That's called my central angle, right? I find that angle there, I divide it by 360. That's what fraction of the full circumference we're dealing with here. So theta over 360 times the circumference of the circle, twinkle, twinkle, little star, circumference equals 2 pi r, and that will give me the length of an arc. So then, to work out the perimeter of a sector, it's an arc length plus 2 more radii. Let's have a look and see how that goes. Here we go. I have what we call a semicircle here. How long is this going to be? Well, I could use the whole theta over 360. My central angle here is going to be 180. 180 over 360 is a half. So really, I'm happy enough to take a bit of a shortcut here, and I'm going to say my perimeter equals, let's do the curve part first. It's half of 2 pi r. Now my radius, be careful. 10.4 indicates all the way across, so my radius is half of that is 5.2. Okay, that's my curve part. Plus, well, there's that straight line across the bottom, the 10.4. Now, anytime we're dealing with pi, there's a good chance I'm going to need my calculator. Hello, calculator. Here we go. Back over here. Gotta work this out a bit more. Okay, so now half times 2. You know what, I can save myself the trouble there. Half times 2 merely equals 1. So I've got pi. I wish I had pi. Okay, pi on this calculator. I've got to press second function, and then that exp button we've been using before. Okay, so that's my half times 2 times pi times 5.2. Right, there's the first part, plus a 10.4 equals 20. Now, what's it asking for here? 1 decimal place, 26.7. Oh, that was weird. 26.7 centimeters, and we'll just say 1 decimal place here. Okay, we've got another one. What's going on here? Well, this is what we call a quadrant. It's a quarter of a circle. A quarter of a circle. So I've got 6 here, right? I can write in here, there's a 6 here, and this part is going to be 1/4 of 2 pi times 6, right? That r, let's rewrite it as a 6, because I know that's what radius is here. Okay, so my perimeter equals 1/4 times 2, right, and 1/4 of 2 is half, times pi times 6. Well, you know what I said, 1/4 of 2 is a half, and a half of 6 equals 3. Oops, so that's 3 times pi, plus 2 lots of 6, let's say 12. So my perimeter equals, right, it's 3 pi plus 12. That's a nice exact answer. But out comes the calculator again, hopefully. That's 1. Calculator, clear that away. 3 times pi equals plus 12 equals 21.4. Okay, is my pen back in action? Maybe. So that was 21.4 millimeters. Okay, again, to 1 decimal place. Righto. Oh, now, we've got something else here. I have something a bit rougher. Now, I'm only doing perimeter here. This time, I've got a sector, but it's not so neat. So this time my perimeter is equal to 52 over 360 times 2 times pi times my radius of 8 plus, let's say 8 plus 8. Right, plus that's 16 for the 2 radii. Again, I know you're going to love this. Here comes the calculator. So, oops, calculator. 52 over 360 across times 2 times pi. Oh, I missed the 2. Get out of it. Times 8. Right, there's the first part, plus 16. And I get 23.3, let's say. Rounding that. 23.3 centimetres. 1 decimal place. Rightio, I know that video is getting away from us a little bit, and I'm sorry, but the next ones just get busier and busier. There's a lot to pick up here. Okay, we have looked at, most particularly here, well, perimeter. Some of them are fairly easy. Some newer things here, arc length, theta over 360 times 2 pi r. Okay, and the perimeter of a sector, it's 2r plus theta over 360 times 2 pi r. Okay, that's it for this one. If you've got any questions, jot them down. See you in class.